Let's first look at the step function, the unit step function. The unit step function is quite useful in terms you can use this to create other functions, the pulses, the other functions. The basic unit step function here is we denote this commonly used notation for unit step function use ut, and the step function has a step change of 1. That's where the unit come from. Have a step change 1 at t equal to 0. So at t equal to 0, in this case we follow the text convention using 1. Actually, there are different conventions used. Some the texts are used half, some use 0 for t equal to 0. That's not critical. So we use the t and t equals 0 and ut equal 1. So in this case, this is the unit step function. Let's look at the Laplace transform for this one. And based on the definition, that's going to be the from 0 to, let's see, use 0 minus. We'll explain this would be the same for 0 or 0 minus. And so ut times e2 minus st dt. Okay, and in this case, let's do so between 0 and greater than 0. So let's see, we can go from 0 minus to infinity during this time, and actually we can go from 0 minus to 0 ut times e2 minus st dt plus 0 to the infinity. So we can break this in two. If you start with this 0 minus dt to minus t dt. Okay, so in this case, this one is going to be equal to 0. Okay, because when ut is less than 0 and ut, this one is 0, right? So this is the first term is 0. That's the reason you don't really have anything to integrate. You can start from 0. So instead of 0 minus, and by the way, the 0 minus is just a little, very close to 0, but it's less than 0, right? So infinitely approaching, infinitely close to 0 on the left side of this time axis. So with that, and now for the second term, and from 0 to infinity, we know the ut is 1. So therefore, we have e2 minus st dt. And remember, the integration of e to at dt is equal e to at over a. The exponent, the at, the coefficient in the exponent a here would be negative s. So therefore, I can get this one as e2 minus st and over negative s, because this a, I'm applying this integration here, and so I evaluate the t at equal 0 to infinity. So I get e2, so that's equal e2 minus infinity times s over negative s minus e2 minus s times 0 divided by s. And this s times 0, this term is equal to 1, right? I have 1 over negative s, the negative, that's the that's 1 over s, the second term. And the first term is 0, so the e2 minus infinity times s is going to be equal to 0 if the real part of s, which is a sigma, is equal to the real part of s is positive, right? So if the real part of s is positive, and so we don't have the rigorous proof of this mathematically. If this is true on the positive side of this complex plane, the right hand side plane, so it will be all right on all the complex plane. So therefore this is 0 minus this is 0 plus. So therefore for the Laplace transform for the unit step function is just 1 over s. Okay, so that's for this second topic. We're gonna look at the impulse, the unit impulse function and its Laplace transform.